Next is the factors influencing on organic reactions. So in that, some of the factors, they are very important to understood to get easily understanding of the organic reactions. They are, the one is the inductive effect, then electromagnetic effect, resonance effect, and hyperconjugation effects. So these are the four effects that we have to understood. So that is very helpful to understood the concept of orientation mainly. So in that, I have taken the first effect, that is the inductive effect. So that we denoted by the symbol I. Yes. So inductive effect is nothing but, so we can see in the molecule like methyl chloride. So here the electronegative difference between chlorine atom and carbon atom we know. For example, in a molecule like heteronuclear atom like chlorine that is attached to the carbon atom, so because of the more electronegativity of the chlorine, so that chlorine attracts the bonding electron towards itself. So that we call the electronegativity. So there is a difference in electronegativity in a molecule, that is between the two atoms, like between the chlorine and carbon. So in this molecule that generate a permanent dipole moment. So dipole is nothing but the polarity on a atoms. So because of the electronegativity difference in a atoms, in a molecule between the atoms, so that generate a permanent dipole moment that we denote, that is small negative charge and small positive charge. So small positive charge on a carbon atom, a small negative charge on a chlorine atom. So that negative charge that shows the electronegativity of the chlorine, that is the high electronegativity of the chlorine that compared to carbon. So that this chlorine that attracts the bonding electron towards itself. So that shows a permanent dipole moment. So that the inductive effect is nothing but it is the movement of a bonding, that is a sigma electron in a molecule that having the electronegativity difference towards the more electronegative atom, or it is nothing but the movement of sigma electron, or it is nothing but unequal distribution of bonding electron between the two atoms. So unequal distribution is nothing but the chlorine that takes the bonding electron towards itself, so it gets negative charge, and it loses the bonding electron, means it loses the bonding electron, so it gets the positive charge. So that inductive effect is nothing but the unequal distribution of sigma electron between the two atoms in a molecule, so that generate a permanent dipole moment. So that we call the inductive effect. This also we call the movement of sigma electron in a molecule between the two atoms that have the means that have difference in electronegativity. So if the atom that have the more electronegativity that attracts the bonding electron towards itself and gets the negative charge. So this effect we call the inductive effects. So I have taken here the example, that is the methyl chloride. So on a chlorine atom we write a small negative charge, on a carbon atom we write a small positive charge. That is because of this is more electronegative and this is a less electronegative. So it undergoes the unequal electron distribution, means more electron distribution on a chlorine and the less electron distribution on a carbon atom. That shows the negative charge on a chlorine, positive charge on a carbon atom. Then if you consider the molecule that is chlorobutane, so here the effect of chlorine atom on a carbon atom, that is the first carbon, if you consider it is the first carbon atom, it is high. So if you goes on, means the distance between the more electronegative atom and carbon atom increases, the effect of that chlorine, means that effect of more electronegative atom on a chlorine, that goes on on a carbon atom that goes on decreases. So the electron attracting of this chlorine atom, that is more on this carbon atom as compared to this carbon atom, as compared to this carbon atom, as well as compared to this carbon atom. So that the distance between the more electronegative atom and carbon atom increases, the effect goes on decreases. So that this is the inductive effect. Then we come across the two types of inductive effect. One is the positive inductive effect and second one is the negative inductive effect. So positive inductive effect, we denote it's a plus I effect. So it is nothing but, so we seen or we discussed that is inductive effect is nothing but the electron distribution between the two atoms. So here the positive inductive effect is nothing but it is a electron releasing nature of the groups. For example, if you consider the molecule like yes, I have taken here the general molecule. So if you consider this molecule, so this group that act as an electron releasing group towards this carbon atom. So this group that act as electron releasing groups towards this carbon atom, so that this group that we called, it shows a positive inductive effect. So positive inductive effect is nothing but electron releasing nature of the groups towards the carbon atom, so that we call plus I effect. Some of the groups that shows a plus I effect, that are a tertiary butyl group. So this shows a high plus I effect. So tertiary butyl group, this isopropyl group, methyl group, ethyl group and methyl group. So the electron releasing nature of the groups goes on decreases. So this shows high electron releasing nature, that means this shows high plus I effect than the isopropyl, than ethyl, than methyl. So this is we call positive inductive effect. So positive inductive effect is nothing but electron releasing nature of the groups in a molecule, that we call plus I effect. The second types of the inductive effect is the negative inductive effect. So that is the negative inductive effect. So this we represent by the symbol minus I. So totally contrast to this positive inductive effect. So it is nothing but their electron releasing nature we seen in a plus I effect or positive inductive effect, but here we can see in electron withdrawing nature of groups or atoms. So plus I effect is nothing but electron releasing nature, like a tertiary butyl, isopropyl, ethyl or methyl groups. So that we call the plus I effect. That is, if you consider the negative inductive effect, that is the minus I effect. So here we can see an electron withdrawing nature of the groups or atom. For example, here if you consider the ethyl, means nitroethyl groups. So nitro group that act as an electron withdrawing nature in this molecule. So this this shows a minus I effect in a molecule, but here this shows a plus I effect in a molecule, because this act as an electron releasing nature, and this group here that act as an electron withdrawing nature in a molecule. So that NO2 that shows minus I effect, and the alkyl groups, that is the tertiary butyl, isopropyl, ethyl, methyl group, that shows a plus I effect, that means electron releasing effect. And here this group that shows electron withdrawing nature, so that we called, or that shows a negative inductive effect. So some other examples they are, one is the NO2 and others are halogens, that may be bromine, fluorine, chlorine, cyanide groups, carboxylic acids group, etc. So these are the examples for, or these groups or these atoms or groups that shows a negative inductive effect, and that examples like tertiary butyl, isopropyl, that shows a positive inductive effect. So this is about the inductive effect. Well, second effect is the electromagnetic effect. So in inductive effect we seen the delocalization of the sigma electron. Yes. So here in an electromagnetic effect, so this effect we can see by the temporary polarization produced due to the shift of pi electron. So pi electron we can see in a double bond or triple bond molecule. So this effect we can see, that is because of the temporary polarization of the pi electron in a multiple bonded molecule towards more electronegative atom in presence of attacking reagent. So in discussing the types of this effect, we can see the attacking reagent or how the polarization of the pi electron that is takes place. So the meaning of electromagnetic effect, or that effect is because of the polarization of the pi electron, that is the temporary polarization of the pi electron in a multiple bonded molecule, that means in a double bond or a triple bond molecule in the presence of attacking reagent. Yes. So this is a electromagnetic effect. So this electromagnetic effect we can see in a double or triple bonded molecule, and this produced a temporary polarity, that means due to the temporary polarization of the pi electron, so that produce a temporary polarity, that means temporary charge in a molecule. So types of the electromagnetic effect, one is the positive electromagnetic effect and the second is the negative electromagnetic effect. So positive electromagnetic effect is nothing but, so in this molecule a temporary polarity is produced whenever a electrophile that attack on a double bonded molecule. Yes, that means a positive inductive effect is nothing but if the attacking reagent is electrophile means electron deficient center. If the attacking reagent is electrophile, the pi bonded electron that get shipped means that get transferred towards the atom where the attacking reagent that attacked. Means if we taken, or if we take this example, that means I have taken here the general example, double bonded molecule. So whenever the double bonded molecule that attacked by the electrophile, that may be a H plus or that may be a Na plus. Now I have taken the two example and I have taken here in general, that is the E plus. So whenever E plus attack on the double bonded molecule, so here the shifting of pi electron takes place towards the atom where the electrophile is attacked. So that is the plus E effect. So we can see in here, so this electrophile after attacking on this carbon atom, the pi bonded electron shift on this carbon atom and this carbon gets the positive charge. So due to the transfer or shift of pi electron, so that generate a temporary polarity. So this is the temporary polarity in a molecule. So positive inductive effect is nothing but the shifting of pi electron takes place towards the atom in a double bonded molecule where the attacking reagent attacked. Yes, that is the plus E effect. The same way the negative inductive effect is nothing but, negative electromagnetic effect is nothing but the reverse of the positive electromagnetic effect. So here the attacking reagent is nucleophile, there the attacking reagent is electrophile. Electrophile is electron deficient center, nucleophile is electron rich center. So attacking reagent is nucleophile, the pi bonded electron pair gets shifted away from the atom being attacked. That means in positive electromagnetic effect, the pi bonded electron shift towards the atom where the attacking reagent attacked, but here it is a totally opposite. The pi bonded electron that shifting takes place to the atom where away from the atom where the attacking reagent attacked. That means we can take here means I taken here the cyanide attacking reagent, that is the nucleophile, it is the electron rich center. So whenever it attacked on double bonded molecule, then the shifting of pi electron takes place that towards the atom, away from the atom where to that atom is attacked by the nucleophile. So you can see here, whenever this cyanide ion attacked on this carbon atom, then pi bonded electron shifting takes place away from the attacked atom. Yes, so whenever cyanide ion attacked on carbon atom, the pi bonded electron that shifts on a oxygen. So this is the electromagnetic effect. So electromagnetic effect is nothing but the temporary polarization of the pi electron in a double bonded molecule, so that involved the generation of temporary polarity in a molecule. That is the plus E effect. One is the plus E effect and second one is the minus E effect. So this is about electromagnetic effect. Next effect is, that is the resonance effect. So here the resonance is nothing but the delocalization of the electron. Yes. So resonance effect is because of the delocalization of the electron, that may be a pi electron or that may be a lone pair of electrons. So that the resonance is nothing but that is the delocalization of the electron in a conjugated molecule, that is the conjugated system. So conjugated system is nothing but the molecule that having alternative single and double bond, so that we call the conjugated system. So this effect we can see due to the delocalization of the pi electron or lone pair of electron in a conjugated system, that results the formation of a different structure of the same molecule. That means we can see here the example, that is the benzene. Yes. So benzene, we know it contains 3 alternative pi bond. Yes. So due to the delocalization of the pi bonded electron, delocalization is nothing but shifting of the electron. Due to the delocalization of the pi electron, so due to the resonance is nothing but the delocalization of the pi electron, so that we get the structure of the same molecule. So here we can see the difference of the presence of double bond. So in this molecule double bond is in between these 2 carbon atom, but here this is only single bond, that is because of the delocalization of this electron. Yes, so that we call the resonance effect. Resonance effect is nothing but delocalization of the pi electron in a conjugated system, so that results the different structure of the same molecule. So these 2 are the different structure of the same benzene molecule, so that we can write the ring in a molecule, that is a ring in a benzene molecule, that shows a resonance hybrid. The resonance hybrid is nothing but the presence of double bond in between all the carbon atom. So that resonance hybrid shows the presence of the double bond, means that. So here you can see the double bond in between these 2 carbon atom. Here we can see the single bond. So that due to the resonance, so we can see the double bond in between all the carbon atoms. So that shows the resonance hybrid. Then the second example in aliphatic hydrocarbon we can see in a butane. So due to the delocalization, we can see the structure of, or we can see the involved in the formation of charges, that is the positive charge on this carbon atom and negative charge on this carbon atom. That is because of the shifting of pi bonded electron. Again the resonance hybrid. So resonance hybrid, that shows the formation of double bond in between all the carbon atom. That shows the involving of the formation of double bond in between all the carbon atom. And next example I have taken here the aniline. So here we can see the delocalization of the lone pair of electron. Lone pair also we called unshaded pair of electron. So whenever this nitrogen that shared lone pair of electron with this benzene ring, so that involved the delocalization of the pi bonded electron, means that involved the resonance. So this is a resonance effect. Resonance effect is nothing but the effect due to the delocalization of the electron in a conjugated molecule. So this is about resonance effect. Next effect is, that is hyperconjugation effect. So hyperconjugation effect is nothing but, so it is a delocalization of the sigma electron that involved in a molecule. So that sigma electron is in between the carbon and hydrogen. So that carbon attached to a sp2 hybridized carbon atom. Means we can see in here the example. So this effect, due to this effect, again the molecule involved in the resonance, that is the shifting of electron. But the shifting of electron here is, that is the sigma electron that is in between the carbon and hydrogen. So whenever this carbon that involved the sigma electron in between the carbon and hydrogen in the resonance, so that results the shifting of, or that results the resonance in a molecule. So due to that we can see the formation of polarity in a molecule. So overall hyperconjugation effect is nothing but the effect due to the delocalization of the sigma electron that is in between carbon and hydrogen, that results the resonance. So that we called the hyperconjugation. So here that we can see in an aliphatic molecule, there the carbon is attached to a sp2 hybridized carbon atom. sp2 hybridized carbon atom is nothing but the presence of double bond in a molecule. So that the carbon that involved the sigma electron transferred to the carbon atom, that is to the sp2 carbon atom, sp2 hybridized carbon atom. So that results the resonance in a molecule. Again we can see in aromatic molecule, that is a toluene is the example. So here the involved means that carbon involved the sigma electron in between the carbon and hydrogen with benzene ring. So that results the shifting of the pi bonded electron in a molecule. So that shows, or that form the polarity. Here the hydrogen gets the positive charge because it loses its bonding electron, and here it gets the negative charge because the pi bonded electron that shifts on the carbon atom. So this effect we call the hyperconjugation effect. Hyperconjugation effect is nothing but the delocalization of the sigma electron, that is of the carbon and hydrogen, that linked to sp2 hybridized carbon atom. So that leading to the resonance. So the difference between resonance effect and the hyperconjugation effect is, there we can see in the delocalization of the pi bonded electron, here we can see in the delocalization of the sigma bonded electron. So this is about the hyperconjugation effect.